Hi guys, now we are going to discuss the problem first element counting given in the Codechef contest started 210. The problem statement states that we are given an array A of n distinct elements, let's say A0, A1 and A of n minus 1, and we are also given a function f of x equal to I, which has the minimum value of the absolute difference between x minus the current value A of I. Let's try to understand what this function means. Let's take an example. Given a array consisting of 4 elements, they are 3, 4, 6 and 8, and let's assume x value as 6. So the function f of x calculates in the following way. At index 0, the absolute difference between 6 and 3 is 3. At index 1, the absolute difference between 4 and 6 is 2. At index 2, the absolute difference between 6 and 6 is 0. And at index 3, the absolute difference between 8 and 6 is again 2. So as we want to have the minimum value, minimum absolute value, we got 0 here. So the f of 6 would return the index 2. So the main task of this problem is to count the number of possible values of x such that for a of I, the f of x value will return I, and if the count is infinite, we consider the count as -1. To solve these type of problems, it's always best practice to plot the given inputs on the number line to get a better idea and visualize better. I've done the same here. The array is consisting of 3 elements, 7, 10 and 2, and I have plotted them on the number line. Let's try to find the answer starting one by one. Consider the case of the extreme left one. So for any value of x which is less than or equal to 2, we will always get a number which is closest to 2. So the f of any value which is less than or equal to 2 will give a index I that will represent 2. So we get infinite number of values for 2. So the count of 2 will be, answer of 2 will be -1. The similar way, for the value 10, there are infinite number of values which are greater than 10, and if we find the f of value which is greater than 10, x greater than 10, it will always result in an index which is equal to 10, because when we do the modulo, the lowest element will always be 10. Let's take an example and prove this. Let's try x as 11. Doing the modulo operations, absolute differences is 2 minus 11, that will result in 9. 7 minus 11 is 4, and 10 minus 11 will give us 1. So we got the minimum 1 for which the on the number line for the element which is closest to it. If x is 11, the closest element on the number line is 10. So this will 10 for 10, any value which is greater than or equal to 10 will always be added into the count. So we got an infinite number of cases for the extreme condition. So for both the values 2 as well as 10, the answer is -1. Now let's try to understand the case for a middle value. So in the number line, the middle value is 7. Let's try putting different values in x and find for which value of x we get 7 as the closest number. Let's try putting x here. The absolute difference will be 0. So we can count 7 into the count. Count can be as, we can count the count as 7. And let's try putting x as 6. So the value 6 is closer to 7 but far from 2. So 6 will also be considered into the 7th answer count. Let's try putting different value in x. Let's say 5. 5 again is closer to 7 but far to 2. So again we can consider 5. Let's try moving x again left. Let's try putting x as 4. But at 4 is closer to 2 but far from 7. So Doing the function f of 4 will give us a result 2 but not 7. So we cannot consider into the 7's count because it is closer to 2. So we'll stop going left, and our limit to left is up to 5. And in the same way we'll start going right. From 7 we'll go right. The value 8 is closer to 7, but it is far from 10. So 8 and can also be considered into the value. Again we'll go right. Let's say x value is here. The value x is closer to the next value but not 7. So 7's count does not include 9. So again our range stops, and the range from L to R is just 5, 6, 7 and 8. So the count for 7 will be 4. They are 5, 6, 7 and 8. So from the previous explanation we can see that the numbers which are closer to 7 will be in the count of the answer. So to simulate this process we placed the numbers on the number line. That means that we are sorting the elements, and by sorting we can conclude that the first element and the last element's answer will be always -1, and for every element in between we consider the immediate previous and the immediate next value. The previous value will be nums of, or let's say a of I minus 1. Current value will be a of I, and the next value will be a of I plus 1. So to count the number of ranges, to count the range which are left to it, we can derive a simple formula, that is left boundary is equal to current plus previous by 2 plus 1, and to get the rightmost range R equal to current plus next by 2. By this we'll get left is equal to 5. This will be left and this will be a right. So to count the number of elements in between them, we can write the range as R minus L plus 1. This will result in L is 5 and R is 8. Yes. So 8 minus 5 plus 1. This will give us 4. That is the current answer that we need, right? Up till now we have found the answer, but the answer that we are expected to print should be in the order that is given in the input. That means the answer should be like 4 comma minus 1 comma minus 1, but we have just don't consider this. We just sorted the elements to place them on, to visualize them on the number line. So we lost the indexes that are previously given in the input. To preserve that, all we can do is maintain a pair, that is a of I comma I, and sort pair, so that both the value, sort the pair based on the a of I value, so that the index will be preserved and the value can also be accessed. So in our final answer we can retrieve the original index and place the answer in them.